Hi students, this is Shekhar sir. In this video, I will explain circular motion. What does mean circular motion? Look at here. After this video, you are going to understand about angular kinematics, angular displacement, angular velocity, angular acceleration. What does mean centripetal acceleration? What does mean centripetal force? What is the relationship between linear velocity and angular velocity, linear displacement and angular displacement? Okay, now you can learn all these angular kinematics quantities from this video. Okay, now so here I will explain about circular motion. So what is the here circular motion? This is the horizontal circular motion. Example of horizontal circular motion is the planets revolve around the sun. Next, moon revolves around the earth is also a example of a horizontal circular motion. Next example is the blades of a fan. Blades of a fan is also a example of a horizontal circular motion. Look at here. The motion of an object along a circular path is called circular motion. For example, here I taken as a circle here. I taken as a circle here. Oh, uh, this is a circle. Okay, now this is the center of the circle. Taken as a point O. Okay, now here, for example, the particle at this position. Okay, now the particle is moving. Here the object is moving along a circular path. This is the circular path. Okay, now if the particle is moving along a circular path, then the motion is called circular motion. Then the motion is called circular motion. Initially, at this point here, okay, now this is the position of a particle. Here it is I can take another x. Okay, now here the distance from center of the particle to center of the circle to the circumference of a particle at any instant of time. For example, here I taken as a particle starting here. So after coming to this point at a time t equal to 0, the particle is at this position. Okay, now after time t 1 seconds, after time t equal to t 1 second, the body reaches the point to P. After time t2 seconds, the body reaches the point to Q at t2 seconds. At t. So the line joining the center of the circular path to the position of a particle at any instant of time. Okay, now for example, at this time, when you join the center to the position of the particle, okay, now this gives the radius vector, that is a r. R is a radius vector. Okay, now next, when you join at this point position, what is the radius vector? When you join the center to the at point P, this gives a radius vector. This gives so radius vector is a vector quantity. It has a magnitude as well as a direction. Magnitude is a constant, but direction is changes at every point. Okay, now next thing is this is a radius vector. Line joining the center to the circumference of a circle at any instant of time. At any time. Okay, when you join from the line here to here, this gives the radius vector r bar. This gives a radius vector r bar. First, angular kinematics quantities, radius vector. Radius vector. The line joining the center to the circumference of a circle at any instant of time is called radius vector alpha. Next thing is the angular displacement. Angular displacement. So, what does mean angular displacement? angular displacement to theta. Angular displacement denoted by the letter theta. Initially, the particle is at this position x at a time t equal to 0. After t1 seconds, the body making some angle with the center, that is the here we taken as a theta 1. Here is the medial set body ఇలా rotate అవుతుంది. After time t2, the body covers the displacement here. Displacement is the theta 2. Okay, now displacement is the theta 2. So there is a change in the angular position. There is a change in the angular position. So angular displacement is nothing but a change. The change in the angular position delta theta equal to, okay, now theta 2 minus theta 1. The change in angular position is called angular displacement. Okay, now అంటే when a body moves in a circular path, బాడీ ఇక్కడ నుంచి ఇక్కడికి వచ్చింది. బాడీ అనేది లీనియర్ డిస్ప్లేస్మెంట్. దిస్ ఈజ్ ఆర్క్ లెంత్ ఇస్ linear displacement of a body. Next, it is moving with some angle at the center, subtended angle at the center. ఒక సెంటర్ తో రేడియస్ వెక్టార్ తోటి యాంగిల్ అనేది చేస్తుంది, పార్టికల్ అనేది యాంగిల్ చేస్తుంది. సో ఎంత యాంగిల్ చేస్తుంది అంటే దట్ ఈస్ ద యాంగులర్ పొజిషన్, యాంగులర్ డిస్ప్లేస్మెంట్ టీటా వన్ చేసింది ఇక్కడ. నెక్స్ట్ ఎట్ టైమ్ టీ ఈక్వల్ టు t1, angular displacement is a t1. Next, after time t2, the body covers the angular displacement. Here it is a theta 2. Angular displacement is a theta. Body అనేది when a body moves in a circular path వెళ్తుంటే బాడీ సమ్ యాంగిల్ చేస్తూ వెళ్తుంది. ఇక్కడ సెంటర్ దగ్గర యాంగిల్ చేస్తూ వెళ్తుంది. ఆ యాంగిల్ ని మనం ఏమంటారు అంటే యాంగులర్ డిస్ప్లేస్మెంట్ అంటారు. నెక్స్ట్ when a body moves in a circle along a arc of a circle, this arc length is called as a linear displacement. Arc length is called as a linear displacement. అంటే బాడీ అనేది సైమల్టేనియస్ గా లీనియర్ డిస్ప్లేస్మెంట్ కవర్ అవుతుంది, యాజ్ వెల్ యాజ్ యాంగులర్ డిస్ప్లేస్మెంట్ ఆల్సో కవర్ అవుతుంది. బాడీ when a body moves in a circle. సో ఓకే, అట్ టైమ్ t ఈక్వల్ టు 0 దగ్గర బాడీ ఇక్కడే ఉంది. అట్ టైం t1 సెకండ్ బాడీని ఇట్లా యాంగిల్ ఇంత యాంగిల్ చేస్తుందంటే ఎంత యాంగులర్ డిస్ప్లేస్మెంట్ కవర్ అయిందంటే theta 1 అట్ టైమ్ t ఈక్వల్ టు t1 seconds. ఆఫ్టర్ టైమ్ t ఈక్వల్ టు t2 seconds, హౌ మచ్ యాంగులర్ డిస్ప్లేస్మెంట్, ఎంత డిస్ప్లేస్మెంట్ కవర్ అయింది ఏంటంటే theta 2. సో వాట్ ఈస్ ద చేంజ్ ఇన్ యాంగులర్ డిస్ప్లేస్మెంట్ అంటే డెల్టా theta ఈక్వల్ టు theta 2 minus theta 1. సో హియర్ SI unit of angular displacement measured with radians. Angular displacement measured with radians, not a degrees. Okay, na degrees తో కాదు, radians తో measure చేయాలి. For example, if a particle complete one circle, how much angular displacement to complete one revolution? Angular displacement is 2 pi radians. Okay, now 2 pi radians. If a particle complete one revolution, what is angular displacement of 2 pi radians? If a particle complete 5 revolution means 5 into 2 pi. 10 revolution means 10 into 2 pi. N revolution means n into 2 pi. For example, if a particle covers n revolution, then angular displacement of theta equal to n into 2 pi radians. N into 2 pi radians. This is the angular displacement. Angular displacement means the change in angular position is called angular displacement. The change in angular position is called angular displacement. Delta theta equal to theta 2 minus theta 1. Angular displacement of is a radian. Okay, now for smaller values, it is a angular displacement is a vector. Angular displacement is a vector if the values are small. Okay, now the values are small. it follows a, it obeys the law of vector addition. Okay, now next, if the angular displacement is a larger values, the angular displacement is a larger values. Okay, now it will become a angular displacement is a scalar. Okay, angular displacement a scalar. Next thing is angular velocity. What does mean angular velocity? Angular velocity denoted by the letter omega. Angular velocity denoted by the letter W naught. It is the omega. Omega is the average angular velocity is given by the rate of change of angular displacement. Okay, now at a time t1 seconds, angular displacement t2. At a time t2 seconds, angular displacement is theta 2. So the rate of change of angular displacement is called angular velocity omega. So average angular velocity equal to theta 2 minus theta 1 by t2 minus t1. With respect to time, the angular displacement is a change. So the rate of change of angular displacement is called average angular velocity. So omega equal to theta 2 minus theta 1 by t2 minus t1. So it is a SI unit is a radian per second. SI unit is a radian per second. The MS formula is a LT minus 1. Damage formula is T minus 1. M0, L0, T minus 1. Or we can write T minus 1. Or we can write M0, L0, T minus 1. T minus 1. Here, angular displacement, it doesn't have no dimensions. No dimensions. No dimensional formula. No dimensional formula. Okay, now the rate of change of angular displacement to theta 2 minus theta 1 by t2 minus t1 is called average angular velocity. Average angular velocity equal to the rate of change of angular displacement by rate by time. So SI unit is the radian per second. MS formula is the t minus 1. M0, L0, t minus 1. Next, what is the direction of the angular velocity? Angular velocity direction what? So the direction of the angular velocity is along the direction of the axis. Along the axis. Along parallel to the axis. Along the axis of rotation. Axis of rotation. For example, here, this is when a particle moves in a circular path. Okay, now here the particle has a linear velocity in this direction. Okay, now at a point like a tangent. Okay, now, like a tangent. Okay, now tangent when you draw at point this point when you draw a tangent, this is gives the direction of the velocity. Linear velocity represented by the letter V. V యొక్క డైరెక్షన్ ఎలా ఉంటుంది ఎలాగే టాంజెంట్ ఓకే ఒక పాయింట్ దగ్గర సర్కిల్లో టాంజెంట్ డ్రా చేస్తే ఆ టాంజెంట్ డైరెక్షన్లో మనకు లీనియర్ వెలాసిటీ డైరెక్షన్ ఉంటుంది బట్ వాట్ ఈస్ ద యాంగులర్ వెలాసిటీ డైరెక్షన్ అంటే దిస్ ఈస్ ద యాక్సిస్ ఓకేనా రైట్ దిస్ గివ్స్ ద రైట్ హ్యాండ్ స్క్రూ రూల్ ఓకేనా వెన్ యూ రొటేట్ స్క్రూ అని ఇట్లా మనం సర్క్యులర్ మోషన్ ఇట్లా మనం థంబ్స్ తో రిప్రజెంట్ చేస్తే దిస్ థంబ్ గివ్స్ ద డైరెక్షన్ ఆఫ్ ద యాంగులర్ వెలాసిటీ. యాంగులర్ వెలాసిటీ ఏ డైరెక్షన్ ఉంటుంది అంటే పర్పెండిక్యులర్ డైరెక్షన్ ఉంటుంది ఓకేనా. లీనియర్ వెలాసిటీ వి డైరెక్షన్ ఉంటే యాంగులర్ వెలాసిటీ ఈ డైరెక్షన్ ఉంటుంది. దిస్ టూ ఆర్ మ్యూచువల్లీ పర్పెండిక్యులర్ ఈచ్ అదర్. ఈ టూ ఎలా ఉంటాయంటే మ్యూచువల్లీ పర్పెండిక్యులర్ గా ఉంటాయి అన్నమాట. ఇట్ ఈస్ ద యాంగులర్ వెలాసిటీ. నెక్స్ట్ యాంగులర్ వెలాసిటీ నెక్స్ట్ థింగ్ ఈస్ టైం పీరియడ్. వాట్ డస్ మీన్ టైం పీరియడ్? What does mean time period? Here, time period denoted by the letter capital T. Time period. Okay. Before that, I will explain about here angular velocity, angular acceleration. Next quantity is angular acceleration. Angular acceleration denoted by the letter alpha. Alpha is called angular acceleration. Alpha is called angular acceleration. So here angular acceleration is nothing but the rate of the change in angular velocity for unit time. The change in angular velocity for unit time is called average angular acceleration. Average angular acceleration alpha average equal to alpha, and the average angular acceleration alpha equal to change in angular velocity, final angular velocity minus initial angular velocity by time. Okay, now final angular velocity minus initial angular velocity by time. So here SI unit of average angular velocity is a radian for SI unit is a radian per second square. SI unit is a radian per second square. Next, dimension formula is a T minus 2. R, dimension formula is a R, M0, L0, T minus 2. M0, L0, T minus 2. Okay, now this is the angular acceleration. So, angular acceleration, what is the direction of the angular acceleration? Angular acceleration direction also parallel to the angular velocity. Angular velocity ఈ డైరెక్షన్ లో ఉంటుంది అలాంగ్ ద యాక్సిస్ కి ఈ డైరెక్షన్ ఉంటుంది. ఈ డైరెక్షన్ ఏమో మనకు ఓకే నా లీనియర్ వెలాసిటీ ఉంటుంది, ఈ డైరెక్షన్ ఏమో యాంగులర్ వెలాసిటీ ఉంటుంది. సో ఈ యాంగులర్ వెలాసిటీకి ప్యారలల్ గా ఉండొచ్చు, యాంగులర్ వెలాసిటీకి యాంటీ ప్యారలల్ గా ఉండొచ్చు. దిస్ ఈస్ ద డైరెక్షన్ ఆఫ్ ద యాంగులర్ యాక్సలరేషన్. The direction of the angular acceleration is given by right hand screw rule. In the same way, the thumb, the middle fingers represents the motion of a particle, and the thumb gives the direction of the angular acceleration outward, or in the direction of the parallel to the angular velocity, parallel to the చేంజ్ ఇన్ యాంగులర్ వెలాసిటీ. చేంజ్ ఇన్ యాంగులర్ వెలాసిటీ ఏ డైరెక్షన్ ఉంటుందో ఓకేనా, యాంగులర్ యాక్సలరేషన్ కూడా అదే డైరెక్షన్ లో ఉంటుంది. ఓకేనా, దిస్ ఈస్ అబౌట్ యాంగులర్ కైనమాటిక్స్. నెక్స్ట్ థింగ్ ఈస్ టైం పీరియడ్. వాట్ డస్ మీన్ టైం పీరియడ్? ఓకేనా, టైం పీరియడ్ డినోటెడ్ బై ద లెటర్ capital T. The time taken for a particle to complete one revolution. Okay, now the time taken for a particle to complete one revolution is called time taken. So here time taken equal to complete one revolution, the particle covers the 2 pi radians. Okay, now total distance by it is omega. T equal to 2 pi by omega. Time period equal to T equal to 2 pi by omega. Or we can write from this relation, we can write T equal to 2 pi by omega. Or we can write omega equal to 2 pi by T. Omega equal to 2 pi by T. Next thing is the frequency. What does mean frequency? Frequency denoted by the letter small f. What does mean frequency? Frequency is the number of revolutions per second. The number of revolutions completed by the body for 1 second. 1 second లో ఎన్ని రివాల్యూషన్స్ కంప్లీట్ అవుతున్నాయో దాన్నే మనం ఏమంటారంటే ఫ్రీక్వెన్సీ అంటారు. సో ఫ్రీక్వెన్సీ ఈక్వల్ టు 1 by time period. Here we can write in place here we can write time period equal to 1 by frequency. Here we can write omega equal to 2 pi f. Omega equal to 2 pi f, or we can write omega equal to 2 pi n. where n represents the small n represents the frequency. Small n represents the frequency. This is about circular motion. So circular motion means the motion of a object along a circular path. Along a circular path is called circular motion. Is called circular motion. Next thing is a radius vector. What does mean radius vector? Radius vector means the distance from center of the circular path to the any to the circumference of a circle. ఓకేనా టు ద సర్కంఫరెన్స్ ఆఫ్ ఏ సర్కిల్ పాయింట్ కు ఇక్కడ నుంచి ఇక్కడికి ఉన్న డిస్టెన్స్ ని మనం ఏమంటారంటే రేడియస్ వెక్టర్. ఇట్ హాస్ అ మాగ్నిట్యూడ్ యాజ్ వెల్ యాజ్ ద డైరెక్షన్. నెక్స్ట్ యాంగులర్ డిస్ప్లేస్మెంట్. పార్టికల్ మూవ్స్ ఇన్ ఏ సర్కులర్ పాత్. ఇట్ కవర్స్ a angular displacement as well as it covers a linear displacement. పార్టికల్ ఇక్కడ నుంచి ఇటు వెళ్తుందా యాంగులర్ డిస్ప్లేస్మెంట్ కవర్ చేస్తుంది, యాజ్ వెల్ యాజ్ లీనియర్ డిస్ప్లేస్మెంట్ కవర్ చేస్తుంది. ఎట్ పాయింట్ పి యాంగులర్ డిస్ప్లేస్మెంట్ ఈజ్ θ1. ఓకేనా. నెక్స్ట్ ఎట్ పాయింట్ క్యూ యాంగులర్ డిస్ప్లేస్మెంట్ ఈజ్ θ2. ఓకేనా. ద చేంజ్ ఇన్ యాంగులర్ పొజిషన్ ఈజ్ కాల్డ్ యాంగులర్ డిస్ప్లేస్మెంట్. ద చేంజ్ ఇన్ యాంగులర్ పొజిషన్ ఈజ్ కాల్డ్ యాంగులర్ డిస్ప్లేస్మెంట్. So here SI unit is a radian, not a degrees. For example, at T1 here we can take as a, for example, here T1 we can take as a pi by 9. T1 we take as a pi by 9. So it means 20 degrees. When we convert pi by 90, this gives the 20 degrees. So here θ1 is the pi by 90. Next θ2 is the pi by 2. We can take another pi by 2 minus pi by 9. Pi by 2 minus pi by 9. Here when we do the LCM, it is a 7 pi by 18. This value is a 7 pi by 18. So this is the angular displacement θ2 minus θ1. θ2 minus θ1. So angular displacement, when a body moves in a circular path, body covers a linear displacement యాజ్ వెల్ యాజ్ యాంగులర్ డిస్ప్లేస్మెంట్. ఓకేనా. సెంటర్ తో ఇక్కడ మనం యాంగిల్ ఎంత యాంగిల్ చేస్తుందో ఈ యాంగిల్ మనం ఏమంటారు అంటే యాంగులర్ డిస్ప్లేస్మెంట్ అంటారు. ఓకేనా. ద చేంజ్ ఇన్ యాంగులర్ పొజిషన్ ఈస్ కాల్డ్ యాంగులర్ డిస్ప్లేస్మెంట్. డెల్టా θ ఈక్వల్ టు θ2 మైనస్ θ1. SI unit is a radian, no dimension. Next, if a particle complete one revolution, what is the angular displacement? 2 pi radians. If a particle complete n revolutions, how much? N into 2 pi radians. Next thing is the angular velocity omega. Angular velocity omega equal to change in angular position. Okay, na ante θ2 minus θ1 by T2 minus T1 is the average angular velocity. Next, angular acceleration is nothing but the change in angular velocity by time gives the angular acceleration alpha. So alpha is the SI into radian per second square times formula T minus 2. Next, time taken. The time taken for a particle to complete one revolution is called time period. To complete one revolution, total how much angular displacement? 2 pi radian by omega. Okay, now here omega equal to 2 pi by t. Here this is the angular velocity. So here we need to find the instantaneous angular velocity. Here instantaneous angular velocity equal to delta t by delta theta by delta theta by delta t limited delta theta tends to 0, delta theta by delta t equal to dt theta by d theta by dt. This gives the instantaneous acceleration. Instantaneous angular acceleration ఎప్పుడు అంటే when a particle when a time limit equal to 0, limit delta theta tends to 0, delta theta by delta t equal to dt theta by dt. This gives the instantaneous angular velocity. Okay, now this is the angular kinematics in a circular motion. Frequency. Frequency is nothing but small f equal to 1 by t. And t equal to 1 by f. Okay, now omega equal to 2 pi by t. So 1 by 2 is nothing but frequency. So omega equal to 2 pi into frequency. In some textbook they will give n equal to frequency f. So omega equal to 2 pi n is the angular velocity in terms of the frequency. Okay, this is the angular kinematics which are useful to understand the rotational motion of a body. To understand the rotational motion of a body, we have to understand the angular kinematics. Okay, now please watch this video, subscribe it, share to your friends. Thank you.